Alright guys, this video is meant to review finding the area of a triangle and then also how to apply that to when we're finding the surface area of a triangular prism. So I just wanted to start off with looking at this triangle here in this picture. I could call this triangle ABC. And in this triangle you'll see there's lots of lines drawn inside of it. And the purpose of this diagram is for you to see that triangles actually have three bases and three heights always. And we know from what we talked about in class that we're very familiar with how to find the area of a rectangle. And we know that when we find the area of a rectangle that we take the length and we multiply it by the width, because similar to an array, we have however many rows of a certain amount or columns of a certain amount. For example, if the width of this rectangle were 3 inches and its length were 5 inches, that would mean we literally have 3 rows of 5, which would mean that the area is 15 inches squared because 15 little inch by inch squares fit inside of that space. So then what we discovered was that half of a rectangle actually gives us a triangle, and that is where the formula comes into play for finding the area of a triangle. The area of this triangle is definitely 7.5 inches squared because 7.5 inches is half of 15, which is what we said the area of this entire rectangle was. So then we were thinking, oh, okay, so if the area of a rectangle is length times width, then that means the area of a triangle is half of the length times the width. However, in the math world, we don't call those parts of a triangle a length and a width. We call them a base and a height. And the reason for that is that when you think about it, this figure right here is laying flat on its back. But if I were to stand it up, if you could picture it standing up, then it would stand up on this side, which we would then call the base, or what it's standing on. And that means that this would become how tall the thing is, which is the height. So really what we use to find the area of a triangle is we say that is half of the base times the height. And a lot of us in class have been just multiplying the base times the height, and then we divide it in 2. The reason we divide it into 2 is because the whole thing would make a rectangle, and half of it would create our triangle. So that being said, it's like, okay, well, I know that to find the area of a triangle, I need to take half of the base times the height, but then the trouble becomes, where is the base and the height? That's where a lot of kids get hung up. And the one thing I need you to know for sure is that the base of a triangle is always, always, always one of the sides. So one of these sides of the triangle has to be, this can be a base, and they can all act as a base at any time. This can be a base, and this can be a base. The thing is, depending on which side you're going to call the base, it will change which one of these dotted lines you use as your height, because the height, remember this too, the height of your triangle must be perpendicular to the base. So that's really critical because otherwise we're not going to get a true height of the triangle. So for example, if I'm going to use side BC as my base, okay, and I want to know if this triangle is sitting on this side and it's standing up, picture it on a table. Picture this triangle on a table and I'm going to stand it up, okay, like a tent. If this is the base, then the only way I can possibly know how tall this thing is by having a perfectly straight line that goes to the opposing vertice, or opposing vertex, if you will. So that point A right there is directly opposite side BC, so that would be the opposing vertex that I need to get a straight line to. So you need to make sure that your line is perpendicular to the base because that is the most straight line that you can possibly get to ensure you are accounting for the entire height of the triangle. So that's why we say it really depends. If BC is my base, then that means that AZ is my height in this case, because that is the line that's perpendicular to BC. Again, if I'm going too fast or you miss something I say, please just rewind and listen to it again and try to really, really comprehend what I'm saying here. If I want to use AC as my base, okay, then that means I need to find a height, a direct straight line that comes from point B, because B is the opposing vertex there. So as you can see, they've drawn it for us. This dashed line here is exactly perpendicular to the base, which would mean that BY is the height when AC is the base. And then finally, if I wanted to use AB as my base, then of course CX would be my height, because it is again directly perpendicular to AB coming from point C or vertex C. Now some of you might be like, oh my gosh, there's so many of them, like which one do I use? Well, the thing is that when you're doing a problem, they're only going to give you certain pieces of information. So for example, they might tell you that side AC is 6 inches long, and then they might tell you that dashed line AZ is 2 inches long, and then they might tell you that side BC is 7 inches long. So in this case, if I'm trying to find the area of this triangle, I need half of the base times the height, but I need a base and a height that work together. So in the case of side AC here, I don't have a height that works with this, because the height I would need is BY, and they didn't give that to me. So this 6 inches means nothing to me because I can't use it. However, they did tell me that BC is 7 inches long, and then I see that I'm given the height that goes with BC because it's perpendicular, and it is 2 inches. So I can do that. I can take half of the base, which is 7 inches long, times the height that goes with that base, which is 2 inches, which means I'm taking half of 14, which means that the area of this triangle would be 7 inches squared. And that is how we calculate the area of a triangle. So let's just make sure that we're able to pick out base and height. When I'm looking at this triangle right here, if they want WV to be the height, which they've marked here, then they would ask you, what is the base of this triangle? What base can I use if I want that to be the height? And what's confusing about this is that our original triangle is right here. So sometimes this confuses kids because they're like, wait a minute, isn't the height supposed to be right here? And yes, that can be a height, but only if you're using the base UV, which they don't want. You know, I don't have any of this information. They didn't name this as a base, and they didn't name this as a height, so I can't use those. That's one option. Mind you, there are 3, like we saw in the last slide. They want us to use WV as a height. So the thing is, the base that goes with this is UT. Because the problem is this. If I wanted to use UT as a base, and I need a height, it needs to be a perfectly straight line that is perpendicular to UT from point V. But the problem is there's no way I can draw a straight line that's perpendicular within the triangle to that base. It's just totally impossible to do that. They're all slanted and none of them are going to make a right angle. So what you absolutely have to do then is you need to extend your base imaginarily so that you can get a perfect perpendicular line and you can find the true height of this thing. Because you have to imagine, they want it to be so that UT is the base. So again, picture that table. We talked about a triangle sitting on a table. It would be like this. This is this triangle, okay? And this is U, and this is T, and this is V. I just flopped it around. I turned it. If you can picture, I just lifted this side up, and now it looks like that. So again, like how tall is this? If this is the base, how tall is it? So the only way to figure that out is to extend my base, mark my vertex, and draw a straight perpendicular line. It's easier to see when it's actually sitting on the base. It's tricky to see when it's kind of slanted the way it is here. But regardless, you need to make sure that you have a straight perpendicular from that opposite vertex. So this question actually was asking what base does height WV go with? And that would be base TU. Remember that the base has to be one of the sides of the triangle. All right, let's check out another one. Look at this one. if this is my base, okay, this is actually a right triangle, which is sort of annoying because if I just use this as my base, then this is my height, and that's easy. But they didn't ask for that, of course. They like to be tricky with us. If this is my base, I need a perfect straight line to the opposing vertex. And so I'm actually, you can't see me right now because you're watching this video, but I'm taking a white piece of paper right now and I'm holding it up to that vertex to make a perfect perpendicular line, and this is it right here. So that would be my height I would draw in. That's what this question asked that we do. And if this was my base, this would be the height that goes with it. It would be one of the sides of the triangle because I have a right angle there. And if this were my base, I would need a straight line that goes up to this vertex, which means that this would be my height. So again, it just really depends on which side of the triangle you're using as your base as to where your height goes. Again, if that was too fast, rewind and listen again, okay? All right, I want you to look at the slide. Take a minute. If that is the base, then you can draw it on a piece of paper if you want to try this. But figure out where the height would be if, in this triangle, I need this to be my base. Where would the height be? Press pause, give it a try. Okay, you should have found that because this is the base, I need a perfect straight line to this opposing vertex, which is actually a part of the triangle this time. So this would be the height. Let's try another one. Press pause, figure out where the height of this triangle would go. All right, if this is the base, I need a perfect straight line that's perpendicular to this vertex. This line right here is too slanted, so that's not going to work. It's not a right angle, it's actually acute, so that will not work, which means I'm going to need to extend my base. And again, you can't see me right now, but I'm using a white piece of paper to make sure I get a perfect 90 degree, which would be actually very close. This would be my height. Super, super close. All right. Now, your homework is to please try to find the area of the following 3 triangles. You can pause and rewind if you need to. This is the first one. Label it on a piece of paper. This is the second one. This is the third one. This is the fourth one. And this one I'm going to give the answer to, but I want you to try to find the surface area of this rectangle or this triangular prism on your own. Go ahead. All right, this one I want to go over with you. So let's take a look. So when I look at this prism, I see 5 sides because I know that the base of this prism is a triangle. So that means there's going to be 3 extended faces of this thing, plus the other 2 would be each base. So 1, 2. So there's 5 altogether. 5 faces. So I like to stay really organized. Those are my faces. All right, my first 2 faces are going to represent the triangles. And then my other 3 are going to be the rectangles that stem from those bases, okay? Now, to find the area of the triangle, I see a perpendicular here, which is kind of like my little clue. You could actually use either the 3 or the 4 as your base. It doesn't matter because the opposite one would be the height. So if this is my base, if 4 is the base, then 3 is the height. And if 3 is the base, then 4 is the height. So it actually doesn't matter in this case because of the way that it is. But to find the area of that triangle, I'm going to need half of the base, which I'm going to say is 4, times the height, which I'm going to say is 3. And 4 times 3 is 12, and half of that is 6. So the area of the triangle right here, which I'm going to call triangle 1, is 6 inches squared. Okay? Which means that this triangle, which is opposite it, is congruent and has the same measurement. Now, don't let this 5 throw you off. They always do that. They put that there on purpose. Just because that thing's 5 inches doesn't mean that it is going to necessarily do anything for me. You could use it in another way that you'll see in middle school, but right now it doesn't matter because it doesn't act as a base, because if it did, I would need a different height here, and they're not giving that, so I can't use the 5 in this problem. So now I'm looking at, I can use the 5 for this part. So now I'm looking at this very front rectangle, and it has a length of 18 and a width of 5. So this is an 18 by 5 rectangle. 18 times 5 is 90 inches squared. Okay. And then I see that there's another triangle in the back. Do you see this one? It is a 3 by 18. I know it's 18 because this long one here is 18, which means in the back it is too. So that's an 18 by 3, which is 54 inches squared. And then finally, the last one is that base one, which is a 4 by 18. 18 times 4 is 72 inches squared. Now, what I want you to notice about this, okay, this is why it's so nice to be organized with these things. I am very confident that I've accounted for every face because of how organized I was, and I'm going to sum everything up, and I'm going to get my total surface area here in just a second. But before I do that, I want you to see something. Notice that every single one of these has an 18 in it. That's because 18 is the length for every rectangle, because all of the edges that stem up from those triangles are 18 inches, okay? And then you'll notice that the 5, the 3, and the 4, 5, 3, 4, are literally, because this is 5, they are all the sides of the triangle. And that makes sense because that's where the rectangles stem off of. So if you ever didn't have a figure to go off of, you could just think about how these numbers work together and solve it that way as well. Just something to pay attention to. So I'm going to get my calculator and I'm going to add these up. Be really careful when you use a calculator, guys, because seriously, so many times I have thought I pushed a button and I didn't, and a calculator isn't always as trusted as your brain and when you're actually carefully cranking these out on paper. But they're faster if you're careful. So I just added everything up and I got 228 inches squared. Let me see if that makes sense. This is almost 80. This is almost 60, which would be 140, 240-ish. Yes, that seems, I'm estimating that seems correct. And so this would be how we solve the surface area of a triangular prism. This last one I want you to try by yourself. It's the same one from our book today. Try your best, crank it out again, and we'll check it tomorrow.